You know, the power grid is pretty much the largest machine ever built. But here's the thing, for all its incredible scale, it's basically running on century-old technology. So today we're plugging into its 21st century upgrade, the smart grid, an intelligent network that's really about to change everything.
I mean, think about it. We have smartphones, smartwatches, smart homes. So why is the massive network that powers all of them still, well, kind of dumb? Our electrical grid is an absolute marvel of the 20th century, but it was designed for a totally different world. It is seriously time for a major upgrade. At its core, the difference is actually pretty simple. The old grid is a one-way street. Power flows from a big central plant through the wires and to you. That's it. But the smart grid, oh, it's a dynamic two-way energy superhighway. It doesn't just send you power, it actually listens. It can take in the extra energy from your neighbor's solar panels, and this is the really cool part, it can even heal itself when things go wrong. So, Section 1, why do we even need this? I mean, that self-healing thing sounds amazing, but what's the urgent push for this massive, expensive upgrade? What's so wrong with the system that's been powering our world pretty reliably for over 100 years? Well, the simple answer is that our energy world has just completely changed. The old grid was built for a few big, predictable power plants. It was never, ever designed for the fluctuating power you get from wind and solar, or for the massive new demand for millions of electric vehicles all plugging in at the same time. The system is really being stretched to its breaking point. Let's get into Section 2, Next Gen Power. A huge part of the solution here lies in the hardware that actually generates our power. We are right in the middle of a renewable revolution. And this is where the smart grid really starts. Just look at this evolution. I mean, wow. On the left, that's the world's first automated wind turbine, all the way back in 1887. Now, compare that to today's giants. In just a few decades, we've gone from 50 kilowatt turbines to these massive offshore machines that produce over 3.5 megawatts each. That is an absolutely incredible leap in power and sophistication. And then, of course, there's the sun. Every single moment, 86,000 terawatts of solar power strike the Earth's surface. It's an almost incomprehensible amount of energy, a constant, massive power source that's just waiting there for us to tap into. And to put that number into perspective, we could literally power the entire planet by covering just a tiny, tiny fraction of its surface with solar panels. And look, this isn't science fiction anymore. Projects like the huge solar fields out in the Mojave Desert with nearly 1 million mirrors, they're already proving this can be done at an absolutely incredible scale. Okay, Section 3, the grid's common language. So we've got all this incredible new hardware, right? We have wind turbines, solar panels, batteries, and they're all from different companies. So how do they all talk to each other, and more importantly, to the grid itself? Well, they need a shared language. In the tech world, we call this interoperability, and we get there by using standards and protocols. The best way to think about it is like USB or Wi-Fi, but for the energy grid. They're the rules of the road that allow any device from any manufacturer to just plug in and play nicely with all the others. And these standards, they touch every single part of the grid. For instance, one standard makes sure all the equipment in a substation works together perfectly. Another one is the reason you can plug your EV into any public charger. And a third, super important one, sets the rules to defend the entire grid from cyber attacks. I mean, without this common language, the smart grid would just be total chaos. Moving on to Section 4, the digital brain. So the hardware is in place. All the devices can speak the same language. Now it's time to give the grid a serious upgrade in intelligence. It's time to add the digital brain. Traditionally, the grid was managed from one central control room. But the smart grid is totally different. It's moving to a model of distributed intelligence, almost like a nervous system with local reflexes all over the place. And this is all powered by a concept called edge computing. So what on earth does that mean? Well, instead of sending data from a sensor all the way back to some central server, edge computing puts the processing power right out there, on the edge, near the source. This allows for lightning-fast responses because decisions are being made right where the action is happening. And it's not just one big brain either. It's a hierarchy of intelligence. You've got simple, low-cost devices out in the field just gathering data. Then you have smarter, medium-cost devices coordinating their local area. And finally, you've got these powerful hubs managing the whole system.
This layered approach creates an incredibly flexible and powerful control network across the entire grid.
So how does this actually work in the real world? Let's look at a really critical application called FDIR. Imagine there's a fault, say a tree falls on a power line. That's what's represented by that red line there. FDR. It stands for Fault Detection, Isolation, and Restoration. And using those edge devices, the system can instantly detect that fault, isolate the broken section of the line, and automatically reroute power to get as many people back online as it possibly can. This is that self-healing ability we talked about right in action. And here's what that means for you. FDIR can turn a potential neighborhood-wide blackout, the kind that costs businesses money and totally disrupts your day, into maybe a momentary flicker of the lights. Or maybe nothing at all. The system reacts in milliseconds to reroute that power, often before a repair truck even needs to roll.
Okay, Section 5, the road ahead. So this intelligent, self-healing grid sounds incredible, right? But building it is a monumental task. I mean, it's one of the biggest infrastructure projects of our time, and it is definitely not without its challenges. First, there's the huge job of making sure every single device speaks that same language. Then there's just the sheer complexity of the whole thing. And of course, connecting everything to a network creates brand new vulnerabilities, which makes cybersecurity a top priority. These are massive hurdles that are going to require immense coordination to overcome. But the potential is just enormous. As this quote suggests, when you combine edge computing, seamless communication, and advanced data analytics, you can create an incredibly strong and intelligent platform, a grid that's resilient, that's efficient, and that's capable of supporting the next generation of technology.
And that really is the ultimate question, isn't it? The technology is here. The path forward is becoming clearer every day. The real question is our will to build this smarter future strong enough? Thanks for joining us on The Explainer.